Hi, this is Roberta, and this is our right triangle similarity shadows and ladders learning experience where students will use ratios, proportions, and triangle similarity to solve the real world problem of getting the kite up there out of the tree. This is the intro station. It's the same in every learning experience where Watson tells students how to move around, access the buttons that are on their wrists. We're going to skip this and dive right into our content.
Here's the deal. It's getting late, and my kite got stuck at the top of that tree to your right. To get it down, I've got to figure out how tall the tree is so I can pick the right ladder. But first, to find the ladder's height, we need to review ratios and proportions, and we'll do it by chopping some firewood. See that pile of wood in front of you? It has big logs and small logs. You'll chop enough of each to make a fire that burns long enough to light up the tree so we can see the kite. To keep the fire going, we need a ratio of 3 small logs for every 1 large log. For 1 hour of fire, that means 6 small logs and 2 large logs. It shows how we can scale up the logs by multiplying both parts of the ratio by the same number to get an equivalent ratio. That's how we figure out how much wood we need. Now let's think bigger. What if we want the fire to burn for 3 hours? On the kiosk, I've started a proportion to help us figure out how much wood that takes. Scoot or slide over to the kiosk. Find the missing number in the proportion, then check your answer.
And we can see students can hopefully make that connection here as well. I'm going to enter my answer.
Awesome job. You got it. For 3 hours, we need 18 small logs to keep the fire going. You nailed scaling the ratio, keeping 3 small logs for every 1 big log. You totally get equivalent ratios. Nice work.
And again, we get a green cue. Watson reinforces what we just learned.
Awesome job. You got it. For 3 hours, we need 18 small logs to keep the fire going. You nailed scaling the ratio, keeping 3 small logs for every 1 big log. You totally get equivalent ratios. Nice work. Now grab the axe and chop the wood into 3 piles to keep the campfire burning.
Now I get to do some fun stuff.
Nice chopping. Now head to the next station to explore what it means for shapes to be similar. Let's jump into similarity. Check out these 2 right triangles. Your job is to resize the green triangle until it matches the gray triangle. Grab the green triangle with 1 hand to move it, and use 2 hands to resize it. Try to line it up exactly on top of the gray triangle. Watch how the sides of the green triangle change size, but the angles stay the same. That's what makes shapes similar. You did it. These triangles are similar because their angles match and their sides are proportional. That's the core idea behind triangle similarity. Great work. Now shrink the green triangle back to its original size and put it back where you found it. Use the kiosk on your right to set up a proportion comparing the matching sides of the gray triangle with the green triangle. Then check if your proportion is right. Once your proportion is set up right, figure out the scale factor and check your answer.
I'm going to do this last one intentionally incorrect so you can see how Watson cues students.
Oops, that's not quite right. When you set up a proportion, make sure you're comparing matching sides from both triangles. Check that your ratios line up the same way every time gray side compared to green side.
Again, prompts to just help them and move them along their way. So I'm going to correct this.
Awesome job. Now let's move on and figure out the scale factor.
All right, and students may need their calculator to do that. Calculator is available under other tools on their wrist, so in case they need to, and maybe they do. So I'm going to take 18 divided by 3. I get my scale factor of 6. So that's always available for them to use if they need it. And we'll check it.
Nice work. You nailed the proportion and found the scale factor. The gray triangle sides are 6 times bigger than the green triangle sides. That means these triangles are similar. Way to go. All right. Now, try building another triangle like the first 2 using the blue legs on the table. Grab 1 leg and lay it flat in the tray to get started.
All right, and we also have other reference triangle up there, just to remind me what I'm trying to do.
Now, pick up another blue leg and attach it to the first one you put down. Make a right angle that points straight up. Now grab a 3rd leg to finish your triangle. If it doesn't fit just right, feel free to swap out any legs. Remember the scale factor and how your triangle should match the others.
And again, we're just building on, we did the stretching. Now we're actually doing that physical model because they're going to need to use this in the next
Awesome
station.
job. You picked legs 8, 6, and 10 inches to build a triangle like the others. The scale factor is 2, so each side is twice as big as the matching side on the green triangle. Great work. Here's what triangle similarity means. The triangles look the same, but can be different sizes. Their matching angles are equal. Their sides are proportional by a scale factor. Now that you've got this, let's move on to the next station. Now that you have all the skills you need, you can help me get the right ladder to get my kite down. To do that, we need to know how tall the tree is. Grab the stick that's on the ground near the tree and stand it up on the red square on the ground. Look, the stick is casting a shadow just like the tree. You can scoot or slide around to see the shadows better. Notice that the tree and its shadow form a 90-degree angle with the ground. The stick and its shadow also form a 90-degree angle with the ground. I'm now going to draw some lines so you can see the triangles that are formed. As you can see, the sun's position ensures that the corresponding angles in the purple and yellow triangles are equal. Since their corresponding angles are the same, the triangles are similar. This means their side lengths are proportional, allowing us to calculate the height of the tree by measuring the stick and the two shadows. Grab the tape measure that is sitting on top of the stick. Now measure the stick. Point where you want to start. Tap your thumb and pointer finger together to start measuring. Then point to the end and tap again to finish. Use the glowing yellow circles as guidelines. Nice, remember that height. Now measure the stick's shadow. Now measure the tree's shadow. Good work. To drop the tape measure, hold your hand out flat with your palm facing down. Now put those numbers into the kiosk to compare the two.
All right, so I need to remember the 3, the 5, and the 12. So I'm comparing tree shadow to the stick shadow. So my tree shadow was 12 feet, and my stick shadow was 3 feet.
Good work. Now try the scale factor to the right of the proportions. Great job with the proportion. Now, multiply the stick's height by the scale factor you found. This is the tree's height in feet. Then pick the right ladder to see if you got it right.
So the stick, scale factor.
Awesome. You got the tree's height right. It's 20 feet tall. Great job using the scale factor. Now, we have the perfect ladder, and you can watch me get my kite down. Thanks so much. You helped me get my kite down using triangle
There's the kite.
similarity and proportions. Thank you for stopping by. Try more problems by selecting the button on your left, exit the learning experience using the center button, or exit to the lobby and log out by selecting the button on your right.
All right, we have more problems then for students to continue to work with the same concepts that are in this learning experience. We can go back to the Curio main room to do another learning experience, or in most cases, you're going to want students to exit to the lobby and log out so the next student can take their turn.